We're going to first of all rearrange this equation right here, taking the constant to the right. So now let us represent this 3 times with some quadrilaterals. Let's go ahead and do that. So here are some quadrilaterals. We are going to represent this with x squared, this with 4x, and this with 5. Already this is a squared. It means that all sides are equal. So we have x here and we have another x here, such that the area of this quadrilateral will be x multiplied by x, which is equal to x squared. Okay, coming to the middle one, we are going to represent this side with x and this side with 4. The area will be 4 times x, which is the same thing as 4x. For now, let us leave this one as just 5 units squared as the area of this quadrilateral. Okay, you can see that these two quadrilaterals joined together will be equal to this big one to the right. Therefore, we can join these two together and they must equal to this big one to the right. To do so, we are going to divide this quadrilateral here into 2 equal parts. By doing so, we can see that this side length must be equal to 2 and this is going to be equal to 2 because 4 divided by 2 is equal to 2. So we can now partition this middle quadrilateral into 2. So you can see now the middle quadrilateral has been divided into 2. Let me just level it. You know, this side length is going to be 2, this is going to be 2, but this side remain x, likewise this side remain x. This is x, and this remain 5 units squared. So what do we do next? We are going to take this, place it here, take this one, place it here, so that we have a single plane shape to the left. So let's do that. All right, now you can see that I have taken this one and placed it here. I have also taken this one, place it here. Let me level it first. You know that this side length is 2 because of this 2. This side length is also equal to 2 because of this 2. This side is x because of this. This side is also x because of this. But our main square also has a side length of x and x. You can see that the total side length here is x plus 2. Likewise, this one has x plus 2. But this entire plane figure here is no longer a square because it has a missing side, which is this one right here. To make it balanced, we are going to complete the square. And how can we do that? We are going to attach a quadrilateral here so that we have a complete square. But whatever figure we added here must be added to the right hand side to make the equation balance. So let's go ahead and do that. So you can see that I have added a quadrilateral here to make the plane figure completely squared, but we have to figure out the area of this figure added. So let's go ahead and find it. Remember that this is equal to 2, this is x, this is x, this is 2, this is x, and this is also x. But we want to find the dimension of this plane figure added. Remember, this must be equal to 2 because it must correspond to this side length. This side length also must correspond to this one as well. So the area added will be 2 multiplied by 2, which is equal to 4. It means that the area added to this plane figure is 4 units squared. Likewise, this one to the right must be 4 units squared. Already this one is equal to 5. Now you can see that this is a complete square because it has equal side lengths. This is x plus 2, this is x plus 2, this is also x plus 2, likewise this one. So it is now a squared. Because of this equality sign, the area here must be exactly equal to the area to the right hand side. Therefore, let us go ahead and find the dimensions of this plane figure to the right, then we can relate the side lengths. This is 4, this is 5, making 9 total. So this is 9 units squared if you add this to this. And 9 is a perfect square, therefore we can write this side as 3. Likewise, this side as 3 because 3 multiplied by 3 is equal to 9. Therefore, it means that this side length is equal to 3 because it must correspond to this one. Likewise, this and this. But since it is a square, we are only going to relate one side because all sides are equal. The total side length here is going to be x plus 2. And we have already seen that this is equal to 3 to the right. And this is equal to 3. What value of x will make this statement true? That value must be equal to 1. So x is equal to 1. So is this the only real solution here? Yes, we're talking about area because we do not have a negative area. But remember, I was the one that introduces these plane figures. We can just assume that this side length is equal to negative 3. Likewise, this is equal to negative 3 because multiplying negative 3 by negative 3 will give us 9 as well. So if we are to relate this side and this side together, we can see that 2 plus x is equal to negative 3. Or we can now say x plus 2 all the same is equal to negative 3. So what value of x will make this statement true? That value must be equal to negative 5 because negative 5 plus 2 is equal to negative 3. So now we have realized 2 solutions. X could either be positive 1 or negative 5. This implies that 1 and negative 5 are the real solutions to this quadratic equation right here. And this is all I have for you today. Thank you for watching. Do have a nice day.